friends, this is Professor Amit Nerurkar, and today we'll be understanding a concept of silly window syndrome, and that too specifically syndrome created by sender. As you know, TCP works on the principle of reliability. That is, after sending every segment, it will wait for an acknowledgement. Now, exactly what is happening in syndrome created by sender is, assume a sender needs to send 5 bytes of data, but unfortunately it only generates one byte of data. Now what happens when it generates only one byte of data? On that one byte of data, it will first apply 20 bytes of IP header assuming no option plus 20 bytes of TCP header assuming no options. So for sending 1 byte of data, I would consume 41 bytes of bandwidth. So if you see, to send 5 bytes of data, I would consume 205 bytes of bandwidth. So if that 5 bytes was created by sender at a time, I would require only 5 bytes of data plus 40 bytes of header, consuming only 45 bytes of bandwidth. So for sending 100 bytes of data and sender generates only one byte of data, it is a quite tedious process, and we are ultimately consuming a lot of bandwidth. So to solve this problem, a scientist known as Nagel has suggested a solution. So name of the solution is Nagel's solution. It says, send the first byte of data as it is, first set of data, whether it is of 1 byte or n bytes. Now create a buffer and start a timer and start collecting all the data bytes in a buffer. Now when one of the two things happen, number one, buffer is full or timer expires, whatever is there in buffer, remove it and apply 40 bytes of header onto it and send that amount of data to the receiver. Regardless whether it has 1 byte of data or 10 bytes of data, when the timer expires or when the buffer becomes full, you need to send the data from the buffer. So this is how the syndrome created by sender is taken care by Nagel's solution. Thank you.